Problem number 1, solve by graphing. Now, in order to graph, it's going to be most ideal if our equation is in slope-intercept form. Remember, slope-intercept form is the form where we have y equal to mx plus b. Now, the nice thing about slope-intercept form is we know what our slope is, that's the m value, and we know what our y-intercept is, that's the b value. Anytime we have the equation written in this form, we can graph very quickly. So my first equation, y equals x minus 3, do remember that the unseen value in front of x is a 1. We don't have to write the 1 there. It's just known to be 1x minus 3. So that means that my y-intercept is negative 3, and my slope is 1. So I'm going to find negative 3 on the y-axis, that's the intercept, and I have a positive 1 over 1 slope, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And you'll remember from class that you really only need 2 points to be able to graph a line. But I like to find a point that's a little bit further away from my starting point just to help me make sure that my line stays a bit more true. Now we're going to graph our second line. Our second line is y equals negative x minus 1. So it's got a negative 1 intercept, and it goes down 1 over 1 because it has a negative 1 slope. So notice I continually go down 1 over 1. The solution to any system of equations is the point in which all of the equations intercept at one point. Well, both of these lines intercept at this point here, over 1, down 2, so the ordered pair would be 1, negative 2. Problem number 2. Remember that we discussed you want every equation to be in slope-intercept form. Now my first equation is in slope-intercept form, so we're going to go ahead and graph it. It's got an intercept again at negative 3 and a positive 1/3 slope. So my rise over run means that I'm rising 1 and running 1, 2, 3. I'm going to rise 1 more and run 1, 2, 3. I can see the direction already of the line, but I still like to go backwards. Backwards would be down 1, back 3, down 1, back 3. Those are the dots that I'm going to be connecting. Well, that's one equation. There are certainly multiple ways to graph the second equation. I could identify my x and my y-intercept. That would be fairly easy to do. Since it's in standard form, if I put a 0 in for x, 2 times 0 would give me a y value of 4. If I put a 0 in for y, I would get 2x plus 0 equals 4, so 2x equals 4, where my x value then would be 2. So I would end up with an equation that looks, or a line that would look something like going through those two ordered pairs. I also want to make sure that you can still do it slope-intercept form. You'll be fond of slope-intercept form, especially when you learn how to use a graphing calculator. So let's change this to slope-intercept form. We have 2x plus y equals 4. Y is already by itself. In other words, there's no coefficient greater than 1 in front of it. So I'm going to subtract 2x from the left side, which means I need to subtract 2x from the right side. And that will leave y all by itself equals negative 2x plus 4. Well, now from slope-intercept form, I see the y-intercept is 0, 4. And it has a negative 2 slope, so it's going to come down 2 over 1. Down 2 over 1. Well, we can see that goes through the same ordered pair. Down 2 over 1. I don't really need to even draw the second line because I can work my way down 2 over 1 until I intersect the other line and figure out the intersection point. But I'm going to go ahead and draw it anyways. So we see a very clear ordered pair at 3, negative 2. Now I mentioned that you could do this in your graphing calculator. If you hit the y equals button, which is up here on the top left, it pulls up a bunch of y equals options for you to be able to graph. Now let's assume for just a second that we plug in our two equations. Y equals 1/3 x, and in order for us to make 1/3 function correctly in the graphing calculator, I'm going to put it in parentheses. 1 divided by 3 is 1/3 times x. X is going to be this x tau theta button here. So we push x minus 3. We have y equals 1/3 x minus 3. Now you'll notice the next equation starts with y equals, so I cannot put in a standard form equation. But I can put in my slope-intercept form equation that we translated. So it starts with y equals negative 2. You should know this by now, but there's a big difference between a negative button on a calculator and a subtraction button on a calculator. So y equals negative 2x plus 4. Now if I hit the graph button, which is right over here on the right, it's going to graph. It's going to graph those two equations. And you'll notice that graph looks an awful lot like the graph that we just created. Except the graph that you drew had grids on the coordinate plane so you could see exactly where they intersected. This one does not. The nice thing about the calculator, though, is it does have the ability to calculate the intersection. So if you notice just above the trace button, it says calculate, C-A-L-C. I'm going to press that button. In order to get a purple, you press the second and then trace, because that's accessing the purple features. And you'll notice number 5 then says intersect. So I want to intersect. It's going to ask for a first curve. The first curve is your first line. You'll notice that it's flashing here on one of my lines. So I'm going to go ahead and press enter to say, okay, that's good. The second curve is my second line. It's flashing on the second line, so I'm going to say, okay, that's good. And then it's going to ask me, do I want it to guess the point of intersection? I'm going to press enter to say yes. And we see that the intersection is the point x equals 2, y equals negative 2. That means we did everything right. Now, again, I see the graph button and the table button. The table is in purple, so I'm going to press the purple second graph. That will allow me to access the table. You saw a problem like this the other day on your quiz review, looking for the point of intersection. Now, the point of intersection is where my x has the same y values. So when I'm looking here, I see y1 is my one equation, y2 is my second equation. These are the y values for any given x values. So when x is 3, that's the only place that I can see the y values are the same. So that would be the point of intersection. Just some interesting things that you'll be able to do with your calculator when you eventually get one. Again, I would not suggest going ahead and purchasing one, but if you have one laying around the house, you can certainly play with it. You'll want to wait until you get to high school and find out what your high school teacher requires, because I don't want you investing in a $100 calculator just to have to purchase another $100 one that that particular teacher would like to use. Number 3, y equals negative 2x minus 1, already in slope-intercept form. So negative 1 is my intercept. It's got a negative 2 slope, which means it's going to be coming down 2, forward 1, down 2, forward 1. I can do the same thing working backwards, go up 2, backwards 1, up 2, backwards 1. And now we connect the dots to graph. For my second equation, y equals x plus 5. That's going to go through the y-axis way up here at 5. And since it has a slope of 1, the value that's in front of x, that we can't see there because 1 is the only term that we don't have to write in. Function is kind of like adding 0 to something. When you add 0, you don't have to say plus 0, because when you add 0 to anything, whatever you started with is what you still have. So, positive 1 slope means I'm going up 1 over 1. Or, that's the same as going down 1, back 1. Down 1, back 1. We can already see where the intersection is, but we're going to graph it. My point of intersection ends up right there at the value negative 2, up 3. And problem number 4, our last equation, we have x plus y equals 2, needs to be in slope-intercept form. So x plus y equals 2, subtract x from both sides, and y will equal negative x plus 2. Well, I can see right away I have a negative x or a negative 1x, so I'm going to have a negative slope. So whatever that line is should start from the top left and work its way down a y-intercept of 2. Well, my y-intercept is here, and we have a negative 1 slope, so down 1 over 1, down 1 over 1. We connect the dots and graph. Oh. Looks like I missed that ordered pair just slightly, but that is all right. We will still be okay. All right, our next equation, y equals x minus 4. My y-intercept is down here at negative 4, and I'm going to have a positive 1 slope. So that will go up 1 over 1, up 1 over 1, up 1 over 1, and we can see our point of intersection is going to be over 3 down 1. Now, I told you that I slightly got my first line off. So when we look at the point of intersection, it looks like it's slightly off of the x value of 3. If we want to check it just to make sure that the solution really is 3, negative 1, we can certainly take that solution anytime we want and plug it back into our equation. 3 plus negative 1 equals 2. Negative 1 equals 3 minus 4, Well, we know that 3 minus 4 is negative 1. That's true also. So that is, in fact, the solution to our ordered pair, or sorry, to our system of equations, even though my graph was not as precise as it should have been to make sure that it intersected perfectly at a grid mark. That is your first 4 problems. We are one page down with our study guide.